is going to be lost, and then it's not going to be good. Anyways, question 5 here, right? Functions and graphs. We can clearly see here we're dealing with a hyperbola, hyperbola. So with this hyperbola, it says here the graphs of f of x and parabola g are drawn below. So while looking at what has been drawn down here, already we need to remember certain things about our standard form. So remember, your standard form already gives you the x asymptote. It already gives you like the y asymptote. But the issue is with the x asymptote, it's always the opposite, meaning if it's a +1 here on the actual Cartesian plane, you will see this at -1. They didn't show it here, but it's something we should know from the equation. For the y asymptote, we take it as it is, meaning whatever it is on the actual equation is what it is on the Cartesian plane. So this will be an actual 4. You see, there's a 4 there, so there's a 4 there. There's a +1 here, there's a -1, because for x it's the opposite. But then for y, you take it as it is, and I need to add these peoples and go back because we are busy. So anyways, with that being said, here they said C is the turning point of G. So the idea is, as you're going to be reading whatever it is that you'll be reading, right? Always make sure to refer to your sketch, because if you don't refer to your sketch and just read, that's a problem, you see. So that's one thing I can say repetitively. If you read something, always go back to the sketch and then just double check or verify what you're reading. Not to say what you're reading is going to be different from what you see. It's just so that it links up in your head. So the other thing is always take hints of other information they'll be giving you. Automatically here, you already know that the y value of C here is a 4, you see, because you can already see that the turning point is on the asymptote. And don't put yourself in a situation where you think things like the sketch is not to scale or whatever, because funny enough, these sketches are always to scale, you see, meaning if it's showing that it's passing through the origin here, don't think to yourself, it maybe just looks like it, but it probably isn't. Nope. What it looks like is what it is. So the y value here is a 4. You just don't know what the x value is here, but it doesn't matter. Instead of me like over analyzing, the one thing I'm trying to do here is to mention a lot of things that we need to just keep in mind about our graphs, you see, of which with this specific graph or with all parabolas, the one thing you should already know is that this x value and this x value, your turning point, the x value of your turning point is right in the middle. So if, for example, this is like an 8, no, that's a bad example. If this is like a 6 and this is a 0, in the middle here, you're going to have a 3. You see, that's just an example, but let's move on. It says here the graph of G passes through the origin. Yes. And then it says B is a point on F such that BC is parallel to the x-axis. So BC is a line parallel to the y-axis. So it's a straight line going straight downwards. So, okay, that's something they're probably going to refer to later. So all this being read, let's see what the first question is asking. The first question says, write down the domain of F for 2 marks. So as we said already about domain and range, right? We mentioned that domain will just be asking you, where do you see the image from left to right? Like which x values does this graph occupy? Now from left to right, the fortunate thing is with all hyperbolas, you know, the domain and the range, you always look at what your asymptotes are. So for domain, you're going to ask yourself from left to right, which x values does this graph not touch? Now, this x value, if you look at the curve, the way the curve is behaving, right? If you look at the way the curve is behaving, going to the far left, it's going to go everywhere. Going to the far right, it's also going to go everywhere. Now, as you can see how these curves are behaving, they are all approaching -1, but never touching -1. So the domain here, we're just going to say x is an element of R, meaning x can be any value. However, x cannot be equal to -1. You see, because your y value, your x values of this graph, the ones that give a valid outcome are all the x values except for -1. You see, because if you were to throw -1 in here, you'd have -1 plus 1 at the bottom, which is like a 0, of which a 0 under the denominator is like undefined. But then if you were to throw in any x value into this equation, it's always going to come out with something valid except for -1. You see, that's what the domain is saying. Which x values give something valid when you throw them in there. And here we're saying it's all of them except for -1. So that's for 2 marks. Moving on. For 5.2, it says determine the x-intercept of f. So yeah, as well on this question, the one thing I can also just maybe say again is, yeah, with math, yeah, there's no need to be like take notes or something. So whatever is happening here, I think, yeah, let me just carry on. Let me not be too extra. So if you're gonna get the x-intercept of f, right? F is our exponential graph. Now the y-intercept, oh no, they said x-intercept. So the x-intercept is this one, where it's cutting the x-axis. So you're getting the x-intercept. I mean, we already know all you need to do is to make y equal to 0 in the equation, because an x-intercept is a coordinate. You see, you don't know what the x is, but you know that the y values are 0. Now, anytime you're dealing with the coordinate, always refer to the equation. You see, because your equation is like a big hack. You know, you just throw in x values, it gives you y. You throw in y values, it gives you x. So this is the equation of our graph. F of x is equal to, what is it? 2, and then x plus 1, and then the 4 down there. 2, and then x plus 1, and then plus 4. Now in this equation, all we have to do is y, we have to make it a 0. And then all we have to do now is to solve for x. Solving for x is practically our only job, you know. All right, our only what? Our only mission, really. So the 4, we can take it over. It's gonna be a -4. This is like 2 x plus 1. As long as you're dealing with a fraction on one side, right, you might as well make the other side a fraction, because, you know, why not? This now we can cross multiply. 1 times the 2 is a 2. -4 times the x plus 1, you can just write it like that. And then you're going to have -4x minus 4 equal to 2. The 4 goes over to the other side. Then you're going to have -4x is equal to 2 plus, is it plus 4? Yeah, plus 4. And then divide both sides by a -4. We are going to get what? What are we going to get? Let us see. In your calculator, the simplified version of this, I think it's going to be like -3/2. And looking at our image, yeah, always try and use your image to boost your confidence, you see. Because if you're seeing an answer here that says -3/2, yeah, that's kind of valid. Because -3/2 is like -1.5. So if you have -1 here, -1.5, yes, it definitely is going to be close to that. So you can be rest assured that it's definitely 2 marks in the bag there. For 3 marks, they're asking us to calculate the value of k. So if you look at what we're doing, whatever question we have, we're always going back to the sketch and the description, because where else are you going to go? You know, where else are you going to go? So them asking for k, the idea is, okay, where is k mentioned? K is the x value of b. So that's what you should now boil down the question to. The question is just asking for the x value of b. Now, the other thing is you ask yourself, okay, fine, where is b? B is a point on f. So these questions, they seem to be very direct, you know, they are just so direct. It's an x value, it's a y value. And they have an equation that you're given. So I mean, like, if you need the x value of b, you're just gonna throw in the y value in there. It's also the reason why this is also just a 3-mark question, because there's really nothing much that's special about the first 3 questions we've done. If you can look at the first 3 questions we've done, we've mainly just worked with the equation of the graph, you see, which is what we just need to be comfortable with. We need to be comfortable with working with the equation of a graph. If you can work with the equation of a graph, you is going to be unstoppable. So I don't know what is on my throat. I keep going and is annoying me. But let's see. This is the y values. This is the x value. So where y is, we're gonna put 14/3 there, and then where x is, we're just gonna put a k, and then we have to solve for k. So solving for k here, I mean, like, I think the issue with functions is being able to simplify and being able to break it down comfortably. That's honestly speaking the first thing, or that's basically all math. Being able to simplify, because sometimes you will know what to do, but it's like, but what happens? So here, let's just take everything to one side if it doesn't have a k. So this fraction, let's leave it. Let's take the 4 over to the other side. Now, what you can also do for yourself is get super comfortable with working with the calculator. I'm saying get super comfortable working with the calculator, but I'm looking at this and I'm like, I don't have a calculator close by, so aye. But 14/3 minus 4, it is going to be 2/3, if I'm not mistaken. Yeah, this is very, yeah, it's a dangerous game, not using the calculator. It's like a super dangerous game. Now, if anyone has a calculator close by, as a belief, just double check this. If it's fine, it's fine. If it's not fine, please let us know, because yeah, we just want to be fine. But it looks okay, because all I just did was this. If you put it over 1 and you have here 3/3, you're gonna have 12 at the top. So 14 minus 12 is a 2, and then the denominator is just a 3. So that's what happened in my head, or I think that's what happened in our heads. So since we have a fraction here and a fraction here, we can now just cross multiply, because cross multiplying is as good as getting an LCD, but it's like, just killing 2 birds with 1 stone. So here 3 times 2 is gonna give us a 6, and then 2 times the k plus 1 is just that, you see. So from cross multiplying, this is what we end up with, you see, because remember, cross multiplying, just focus on what's at the bottom. The bottom times the top there, the bottom times the top over there, you see. And then that's how we ended up with this thing over here. So us having to have what we have here is just 2k plus 2 equal to 6. And then you're gonna have 6 minus 2, 2k. This is like 4, 2k, and then divide both sides by 2. You're gonna have, I wrote the equal to sign too early, as always. So here you're just gonna have a k value of 2, which is, let's see if it's believable. K value is 2, meaning the x value of b is a 2. According to the sketch, I mean, could this potentially be a 2? Yeah, it looks like it. Because remember, we say this is a sketch to scale. So what you see, it needs to be believable. So if the distance here is like a 1, then it means to the right side, the distance 1 should end up here, you see. Meaning 1 again, you would have a 2 there. So that kind of does make sense, that the k value here is a 2. And you can see what I'm doing here. Get an answer, just try and fact check it. Don't just move on, because there's no need to rush. You kind of have time. I know it's kind of like a condescending thing to say. Oh, it's not really condescending. Saying you have time. You do have time. The only thing is sometimes when you think you don't have time, that's when you end up not having time, because you're thinking about it the whole time. So you end up wasting time. And then the next thing you know, you don't have time. So yeah, it's just the way you think about it. And it looks like the next question is going to be, again, us working with the equation. 4 questions down the line, and we're literally working with the equation of the graph. Now, this is not something that should alarm us. It should educate us to know, okay, it looks like knowing how to work with the equation of a graph is 3 marks, because that's what all these are, all these questions. Them asking for C is the turning point of our parabola. Now, we don't have any equation of the parabola. But then if you remember what we mentioned in the beginning, we said that you need to know things like how, if this is an x value and this is another x value, the turning point will always be directly in the middle. Or rather, your turning point will always be in the middle of your 2 x-intercepts. Now, the fortunate thing is here, wow, coincidentally, I just wrote the value, the coordinate of C in the previous question. just because of all the information we had filled in. Because if you can recall from the previous question, we had already stated things like how as long as our turning point here is on the asymptote, it means that the y value is a 4. And then we also did mention that as long as, maybe we didn't mention it, but they told us that BC is parallel to the y-axis. If BC is parallel to the y-axis, it means that BC is a straight line going down, meaning the x value of B is also the x value of C. So yeah, this was literally got an answer by mistake. Okay, not a mistake, but yeah, wasn't even looking for it. So it's gonna be a bit awkward for 3 marks. I mean, for 2 marks to just put the coordinate here, but that's literally what they will give you 2 marks for, just writing it out, because working it out is purely by observation based on what you worked out. What you know is that the B and C have the same x value, so you put an x value of 2 there. What you also then know is that the y value of the turning point is on the asymptote. So you can just put a 4 there, because the asymptote is cutting your y-axis at 4, you see. Now, all this is good enough to get all your marks all the time. The only thing is, most of the time, we are always thinking, okay, I need to do some calculation to get my marks. And that is not true. If you can just get the answer by seeing it, and it's like 2 marks or 1 mark, just write the answer. Don't worry about working out anything, so that you don't spend time like stressing about what to write down, but yet the answer is like right in your face. So yeah, that's going to be 2 marks. Now, let's see what these follow-up questions look like. I feel like what's important about this question is the rest. So for 3 marks, right, they're asking us to get the equation of this parabola in this format. Now, the one thing I can say is them asking you to get an equation in this format, it's them being nice, but whichever format they'll usually ask you to get an equation is in, whatever format they'll be referring to, there's always a way to get it, especially based on the information given and all the questions asked. Now, the one thing you can always remember is that with all functions and graphs questions, or with math in general, especially how these papers are laid out, the thing that you have at your disposal is the information given originally and everything else that you worked out. So don't now think to yourself, oh snap, if I forget or if I lose one question, then I don't get the rest. Think of it in reverse. Think of it as, if you can just understand the follow-up questions, you can be rest assured that the follow-up questions, the ones that come after whichever ones you answered, they're going to get easier and easier, as long as you can make use of what you have just worked out. Just like what we're going to do here. The first thing is we need to know what all these variables mean, specifically P and Q, because A is just the shape. You see, A is just the shape of our graph. Whether it's smiling or frowning, it's purely based on the value of A, of which, if you look nicely, I mean, like, it's so in our faces, it's a frowning graph. So in as much as we don't know what A is, what we already know is that A is a negative value. You see, A is a negative, or as they like to write it, they'll say A is below 0. This is just saying A is a negative value. P and Q, we know that P and Q will always give you your turning point. You see, turning point, turning point. Now, the turning point, fortunately, we have it. It's the coordinate of C. So we have P and Q. But the issue is, with P and Q, whatever it is on your Cartesian plane, always keep in mind that for P, it's the opposite. But then for Q, it stays the same. What I mean is, in the equation of your graph, right, you have here y is equal to A. We don't have A yet, so let's just put A. Here, you need to be careful, because your turning point is 2 coordinate 4. For P, you're going to have to put a -2, but then for Q, you take it as it is. I'm going to put a +4 there. So far, you can imagine this is going to give you 2 marks so far, because of this and because of that. But why get 2 marks when you can get all 3? Like, hello. So for the A, all you need is just a coordinate that the graph passes through. You see, you need a coordinate that the graph passes through. So you needing a coordinate that the graph passes through, it cannot be a random coordinate, but then it doesn't have to be anything difficult or crazy. Like, fortunately, you don't want to obviously use the turning point itself. It's not going to work, because if you use the turning point, you're going to put a 2 there, which is going to be 2 minus 2, and then this is a 0, 0 minus 0 times a, the a is gone, but you're trying to work it out. So if you're going to choose a coordinate that the graph passes through, use any other one, of which, fortunately, because of our description, as we all are probably thinking, the origin is a coordinate. Now, using the origin is something that most people sometimes don't even do, but I mean, it's as good as a coordinate as any other, you see. So x is a 0 there, and then the y value is also a 0, and then here you have 4a, because this is negative 2 squared, which is a 4. And then what you got? The 4 is gonna go over there, divide both sides by a 4, you're gonna have the -1, so that's like a, and then you is done. So as expected, we expected a negative value, whether it was 1, 2, 3, doesn't matter, as long as it's a negative. So here we're done. You see, therefore y is equal to -1 x minus 2 squared a plus 4. There we go. Okay, so far so good. 5 marks, 5 questions down the line. And the one thing we can clearly see is how with functions, your sketch is important. Your sketch is very, very important. So with the next question, we have inequalities here. So stuff like this, right? I think if you check on the main channel, you will see questions like these in the inequalities playlist. Inequalities. Let's see. Now, for you to be able to answer these kinds of questions and get your full marks, you need to understand what the question wants. Because most of the time people look at these and they bomb out because they just don't know what they mean. When I say they, I'm actually referring to myself once upon a time, because these were like, hey, you just look, you look twice and then you keep going, because it's like, yeah, why not? Why struggle unnecessarily? But the way to understand these questions is you need to keep in mind that anytime they're referring to f of x, they're just talking about the y values of f. Anytime they're referring to g of x, they're just talking about the y values of g. You see, so the question is asking, where will this expression be a number that is smaller or equal to 0? That's what the question is saying. They're saying for which values of x will this expression be smaller or equal to 0? So what it means is, which x values, if you throw them in both equations, which x values, right, when you throw them into both equations, will result in this whole thing being a number that is smaller or equal to 0. So even though in interpreting it is like, okay, fine, I get it. Y values of f, y values of g, where is this expression smaller than 0? Understanding that question is like step 1. The next thing is knowing how to then answer that question. So the first way to know how to answer these kinds of questions is to remember that firstly, you're dealing with a fraction. Now, a fraction, if it is going to be a number that is smaller than 0, let's deal with it being smaller than 0 for now. If your fraction here is going to be smaller than 0, let us rescue our fallen comrade. If your fraction here is going to be smaller than 0, it means that the only two cases where your fraction can be smaller than 0 is if the top is a positive number while the bottom one is a negative, or the top one is a negative while the bottom one is a plus. These are the only two scenarios where your fractions are smaller than 0. I'll repeat, this is a fraction. A fraction will be smaller than 0 if the top is a positive number while the bottom one is a negative. Vice versa, if the top one is a negative and the bottom one is a positive, the fraction will also be smaller than 0. So I mean, like, cases where this will be equal to 0, let me just put this here, Cases where this will be equal to 0, it's clearly cases where only the top is a 0, you see. So f of x over g of x will be equal to 0 if f of x is a 0, meaning if the top is a 0, you know. Let me not even write it. Let me just show it as an image because it's easier to look at. So this will be equal to 0 if the top is a 0. It doesn't matter what the bottom is. The top just has to be a 0. But then whatever we do, the bottom should never be a 0 because that will just cause the whole thing to be undefined. Now, with all that I've said, right, sometimes it seems like a mouthful, which it is. But then the moment we will like start working on this question and actually start solving it, you will start to see the logic behind all that we have said, you see. So let's actually start now answering the question so that we can move on. But before that, let me just do this. Sorry, madam. So anyways, let us move on. So with this question, right, these are how you answer these kinds of questions. You answering these kinds of questions, what you actually need is your sketch. This is why if you check in your in past papers, right, you'll always see that oh yeah, they normally actually do this for paper 2 actually. They will give you in your answer sheet, right, in your answer booklets, they'll always give you like images of sketches that you have in your question paper so that you're always able to like draw them and all that so that you can see them better also. The reason for that is for questions like these. So with this kind of a question, it's purely a question where you're going to use your sketch. Literally, your sketch is going to answer questions for you. So this is how you answer this kind of a question. So you want cases where this is happening. Just focus on this first before worrying about this, because you want where this fraction is below 0. Now, what you want to do is you want to, in your image here, just look for cases where the first thing you look for is cases where everything is equal to 0. Just look for cases where your graphs are cutting the x-intercept. Like take note of those points. So that's happening over here, and over there, you see. So what you then do is you want to go to these x-intercept, because remember, these are the cases where your graphs are equal to 0. They are not necessarily below 0 or they are not necessarily above 0. These are cases where your graphs are equal to 0, you see. These are cases where your y values of your graphs are equal to 0. So let's keep that in mind. Secondly, what you want to do is go to each of these. Oh, snap, I messed up the image. Let me redraw again because I moved my image. Equal to 0 there, equal to 0 there, equal to 0 there. What you then do is just draw like dotted lines. So just put dotted lines here, dotted line over there, dotted line over there, a dotted line over here. Perfecto. Now, this is all you need to do. So all you need to now do is you need to look in between each of these, right, for cases where this has positive while the other one has negative, or for cases where this has negative while the other one is positive. But let me simplify it. All you want to do is you want to look at your Cartesian plane from left to right. Looking at your Cartesian plane from left to right, you want portions of the sketch where the one graph has positive y values while the other one has negative y values, you see. So if you look nicely, this is not happening here. You don't have one graph having positive y values while the other one has negative y values. You don't see it in this space here. But then right in the middle here, you can see that it's not happening here, but then just here now, you can see that this graph has positive y values while the other one has negative y values. So this is a portion of the sketch that qualifies. Moving on, you can also see that this portion does not qualify here because this portion only has this having positive y values and this also has positive y values. So it doesn't qualify for our answer. So we keep moving forward. If we look after this dotted line now, we can see this portion qualifies for our answer because we do have positive y values there, and down here we have negative y values, you see. So this portion here and this portion only, those are the only portions that qualify for our answer for now, before we go deeper. Because if you look nicely, right, we said we just want cases where one graph has positive y values while the other one has negative. We want a case where one graph has negative y values while the other one has positive. And we are seeing it only happening at these x values here and at these x values going to infinity. So as a portion of your answer, that's what you need to consider, you see. But before we write out an answer, we know that we should just be careful. But let me not overthink it yet. We'll overthink it after we give these answers for now. So giving our answers, right, we're going to have to say here, the portion of our question or the portion of our sketch that is going to give us an expression that is below 0 is where x is between, remember this here, we said this was like a -1. So looking at our sketch, you can see that the portion where your sketch qualifies is between -1 and 0. Because we can see that this is just going to go down all the way to like infinity, but then it will never cross -1. Same here, this will just always go up, but it will never cross the -1. So the portion of our answer here that is valid is x is an element of -1 up until 0. The reason why we're putting a round bracket at 0 is because specifically at 0, the graph of G is a 0. You see, meaning if you do put a 0 down there, the whole thing is going to be undefined. So we want to make sure that we only say from -1 to 0 instead of saying from -1 to 0, but including the 0. So the round bracket there is us not including this specific number. We're just trying to say in between that space only. Now, the other portion of our answer that is valid is where our x values are an element of positive. So you see here, we don't have this x-intercept, right? But then because of our general knowledge, we know what that x-intercept is because of what we said. We said that a parabola is symmetrical, meaning that the distance from the center or the x value of the turning point until one x-intercept is the same on the other side. So if this distance is 2, it means that this distance is also 2, meaning this is a 4. So that is already something we should know because they're not going to tell us. We should know it. So here we're saying that the graph or the image that qualifies for this question is from, I need to find the green now. It's from 4 all the way until positive infinity, like that, you see. So here we're not including the 4 because specifically at 4, the graph of G is a 0. And we said that you cannot have a y value of 0 at the bottom, you see. Because if you throw a 4 in the graph of G, you're going to have a 0 come out, you see, meaning you're going to have a 0 there. And we said here, all this is saying is y values of G, you see. So here we cannot have a y value of G that's specifically equal to a 0. So that's why here we're excluding the 4, because if you throw a 4 in there, a 4 comes out as a 0, and having 0 down here is it's undefined, so it won't work. That's the reason why we have to make sure to put a round bracket here, because we're saying our answers are from 4 to positive infinity, but then the 4 we don't include it specifically. So for this question in particular, it's out of 4, but then this is all you need to say, because all you have said here is taking into consideration these 3 scenarios. These 2 scenarios, we covered them. And then this one will never happen because your expression is equal to 0 if the top is, oh, wait, yeah. This one we have to consider it also. So these ones are covered, but then we should not forget this because we said, remember, this is twofold. This is asking where is the expression smaller or equal to 0. Now we dealt with smaller than 0 first, which is these 2. We got our answers. Now we said this will only be equal to 0 if the top is a 0, which is f of x. Now, if we look at our sketch, right, there's only one instance where the y value of f is a 0, and that specific instance is here. An x value of -1 is, no, this is not -1. This is, we worked it out to be -3/2. -3/2. So an x value of -3/2 gives us a y value of 0 for f, of which us having a y value of 0 for f means that our whole expression will be equal to 0, which is part of our answer, or it's part of the solution that qualifies for this. So this is an answer, this is an answer, and then we also have to say here, or x is equal to -3/2, because that's what the question is asking. For which x values will this expression be valid? And we say, just break it up. They're asking for which values of x will this expression be smaller or equal to 0. So we say it's smaller than 0 over here and over here. And then we said it's equal to 0 specifically over there only. That's why this question is a 4-mark question. Now, you looking at this question, you can imagine how it's not like an entry-level question. It's the kind of a question where you do need to have gone through, quite a few of, not a lot, but like a few of these, where you do work with, okay, y values of f, y values of g, going on and on and on. But the fortunate thing is, a lot of these kinds of questions, you can see they always come up in past papers, which is cases like, which is things that is like heavily covered in the functions and graphs course. Like if anyone has been on the course platform, which a lot of you have, what you'll note is that the functions and graphs course is like the heaviest one. Not necessarily heavy saying it's difficult, it's just the one that has a lot of examples. Because yeah, you can imagine a lot of these things are also there. So if you need more clarity on that, then that is definitely your best bet. But let me just double check here to see if there are any questions. And nope, no questions at all. Let me just do this just for the vibes. Oh, unless there are questions. So remember, as always, if you do need to ask questions, you can always just switch on your mic, and then you can always just interrupt and you can ask. Yeah.
Hello,
I had
sir.
something. What is up?
So can I ask about a different way to tackle this question? Can we just use the equation of f of x over g of x and then equate it, well, not equate, say it's less than or equal to 0,
And then work it out algebraically.
Yes.
The fortunate thing is, okay, I don't know if it's fortunate or unfortunate, but then if you look at it nicely, right? Where is this thing? I'm trying to go to the equation of g. So if you look at how the equation of g is given, can you see that you can already see that the equation of g here, it has a fraction and all that shandies. And then if you look at the equation of f, it looks like this, you see. So if you were to like work this out algebraically, let's actually just show it briefly. We're not going to do it, but we're just going to show it so that you can see what it looks like. So working it out algebraically, you would, for example, have something like, what is the equation of f? It is, let me just copy this thing here. Copy. Okay, and then let's see the one of g cos 3. So f is on top here. Let's put g down there. So g looks like what? G looks like this. This copy and then paste. You can just switch on your mic later. Let me just do this for now. Oh. Yeah, good. Hold on. Mute. I saw your hand. I'll get back to you just now. So with something like this, let me see here. Go away. Hold on. Does someone want to say something?
Sir?
What's up?
Yeah, sir, I was asking, sir, like, that part where you were talking about, I didn't understand clearly where you were talking about the x is an element of 4 to up to infinity.
This part specifically.
Yes, sir.
Okay. Okay. So the reason why this is part of our answer is because if you look at our sketch, right, we said that we want a portion of the image where this graph of f has positive y values, while this graph of g has negative y values. So if you look nicely, right, remember this is the x-intercept. So anything below the x-axis, this is the x-axis. Anything under the x-axis, we know it has negative y values. Anything above the x-axis, it has positive y values. So if you look at what we have up here, right, this here is going to go forever in this direction, and it's always going to be positive y values. And then this here is going to go down forever, and it will always be negative y values, you see. So here you'll always
Yes,
be
sir.
having positive y values here, while you're having negative y values here. And this is all happening
Yes.
for all the x values, starting from 4, going in this direction, you see, because from 4 going in
Yes.
this direction, it's from 4 going to positive infinity. So we said that from 4 going to positive infinity, you have this going on, of which as long as this is happening, it's going to qualify for our answer.
Okay, sir. Thanks, sir.
Fantastic,
Now I
fantastic.
understand.
It's all good, it's all good. So for this question that you had asked about algebraically working it out, right? If you look at it nicely now, this is what you're gonna have, right? And the unfortunate thing here is if you, let's say, maybe you worked out where it's equal to 0 first, you can already see how you're going to bump into an issue here, because whether you like it or not, this down here this is a fraction. You have something at the top, you have something at the bottom. So the one thing you would probably do first is to multiply what you may call the denominator on both sides. If you were to multiply the denominator on both sides, you'd only be left with x minus 2 squared plus 4 smaller than 0. And then normally when you do stuff like this, you end up with answers that are a bit inaccurate, because your answers would not necessarily take into account everything here because of all this chopping up and all that stuff. So working it out algebraically, I won't necessarily say it's 100% wrong. I'll just say that it's not going to give you all your answers. So it's just one of those cases where if you have written exams before, or tests or whatever, normally when you work it out algebraically, you'll find yourself getting like 2 marks or like 1, because one of the things will be fine, but then the rest you would not have gotten it from you working it out algebraically. Because I mean, like, let's actually even just do it. You see, if you have done it algebraically, we said you would multiply the denominator on both sides, and then you'd only be left with like x minus 2 squared plus 4 smaller than 0. And then here you can take the 4 here, it's going to be a negative, and then here you're going to have, let's say, x squared minus 4x plus 4. And then you are going to have what now? I mean, if you're going to work this out, you can maybe, I think this has to come back. I don't know why I took it there. So if this comes back, you're just going to have x squared minus 4x here, because 4 plus the 4 there, I think that's going to be an 8. Now, if you're going to work out this inequality, this is how you solve this inequality. To solve this inequality, what you need is, I think with this one, you cannot work it out with your head, because factors of 8 that give a 4, I don't think you have those, because it's just like 1 and 8, 2 and 4, and then it's try. So here I think you'll have to use your calculator to like see what your x-intercept of this graph is, because this question is asking where is this parabola below 0. So you would get your 2 x-intercepts. Yeah, I think if you, before we even waste time, right, excuse me to say that, I'm pretty sure you can see it's just a bit messy when you try to do it algebraically. The one thing you can just get used to over time, right, of which it will get easier, is to just know how to work with your image or know how to work with your sketch. Because you can also imagine, depending on however it is that I'm doing it now, right, it's not as though I looked at it one day and then automatically always got comfortable, and then automatically got comfortable with the method. No, it was a matter of looking at it once, and then over time you just see that, okay, wait, you just need to be able to work with the sketch. So I know it's a bit overwhelming when, you know, we're seeing all these dotted lines and the colors and all that. But this is why these are some of the things where you do want to go back to it and then look at it for the second time. Because whenever you look at something for the first time, it's fresh, it's new. So it's not going to click immediately. But then if you give yourself a chance to look at it again, it does get better. So I think that's what I can say for this specific question. And I hope that answers your question. I'm not sure who asked, but I think it was Tabi. I think. I'm not sure. But whoever asked, did I answer your question? And I'll answer this also. Please explain the x as element of -1 to 0 part. Yeah, so the part where it says x is element of -0 to, -1 to 0, it's because of our asymptote here, you see. It's also because if these lines continue, remember this is going to continue and go up forever, but then it will never touch what you may call the asymptote, you see, meaning that if you look at how your image is behaving, let me just extend this asymptote going up here. If you look at how your image is behaving, right, its x, the x values of your image here will never go below -1, just because of how this is behaving. You can see it's going up, yes, but then its x values, they are not going to go below -1. Same down here. You can see how this asymptote is here, right? This asymptote is clearly showing us that this graph is going to be going down forever, right? But then it will never have x values that go below this -1. So what we're saying is that this will be having positive y values, yes, and this will be having negative y values, yes, but then that's only going to be happening within this small space here between the -1 and the 0. It will not go below the -1 because this is an asymptote. It's not one of our orange lines, but it's specifically also something that you can see is helping us to see that, okay, wait, it's just from -1 to 0 there. So I hope that answers this question.
Levi,
Yo, what's up, Chloe?
I know you want to move on to the next questions and stuff, but I don't know. This is how I concluded it. So, like, I saw you were busy with the f of x and the g of x. So, I was looking at both in asymptotes, right? So, like you were working with the -1 and the 4. So that's also how you got your from your 4 to your positive infinity, and from your -1 to 0. So I was looking at it as like working with the x-intercepts of your parabola.
Paula?
So yes, so like I was working with that. So that's just my conclusion. So to whoever was struggling with like doing it your way, because I feel that's much more simpler than doing it algebraically, because you can like, that's just my conclusion. So I was just trying to simplify it for someone if that's going to be useful.
No, definitely. No, definitely. Because, yeah, definitely. I would add, but I think you said everything. So x-intercepts, they're important because they are the ones that clearly just distinguish where are the positive y values and where are the negative y values. So just look out for x-intercepts and then work with those, because you can see even our answers, all our answers here have something to do with specifically x-intercepts. There's an x-intercept there, an x-intercept, technically, I mean, the asymptote is cutting the x-axis there. There's an x-intercept there, there's an x-intercept there. All these numbers have to do with the x-intercept. And then it's not a coincidence that in the previous questions, if you look at the things they asked us, they firstly asked us for like the x-intercept of f, which was this. We ended up needing to use it. And then we mentioned how they mentioned this is the origin. We ended up needing to use it. We worked out this for, as we said in the beginning, we need it. We ended up using it. So I think that's a proper conclusion. Work with your x-intercepts and then practice more of these kinds of questions, and then they'll definitely get better. So yeah, I think that is that for question 5.6. It looks like 5.7 is probably going to be. I will see. I'll do 5.7, and then whoever wants to stay can stay. Whoever needs to go, they can go. I feel like I just need to finish this paper today, to be honest. And then remember, all the papers, once they're done, I just cut out what I need to cut out, and then I just upload them onto like the past papers channel, meaning that whatever other questions we're gonna look at, if you need to like go through them, they will be there. Because remember, everything is like, being stored and saved and everything. So I'm just gonna go through 5.7, and then I think I'm gonna finish the paper today. Question number 4, right? I mean 5.7, sorry. It says use the graphs of f and g to determine the number of real roots of this equation. Give reasons for your answer for 4 marks. What? Hey, what? Good Lord. Hey, yeah, so anytime you read questions like these, I mean, like, obviously you want to read again. But then the funny thing is, maybe not like haha funny, but the weird thing with these kinds of questions is, don't maybe put them on a pedestal. Well, the reason I reacted the way I reacted is because, I mean, yeah, it does look weird. I mean, like, no one likes to read words like real roots in a question. It's always like, yeah, it's just one of those questions. Anything to deal with roots, yeah, there's a stigma behind it, but not to a point where maybe you should not know how to answer the question. It's just maybe the way I reacted. It's just it was a reflex action. But anyways, reading it again, before I even read it again, this is the idea with these kinds of questions, and this is why going through past papers is helpful, because during past papers, right, you'll find yourself bumping into similar questions. And I mean, compared to the past papers I've gone through, I already have an idea of what has happened here. The reason I'm saying what I'm saying is, before I read this question again, if we look at what f of x is, the equation of f of x is 2, and then x plus 1, and then plus 4. The equation of g of x is negative 1, x minus 2, and then plus 4, x minus 2 squared, and then plus the 4. Is it plus 4? Yeah. Yeah, plus 4. So the idea is, right, before we read this question again, what you want to recognize is that what you're seeing on the left side here, this is literally just the equation of f of x shifted vertically and horizontal. Yo, good Lord, horizontally. Finally. So this is literally just like the graph of f shifted horizontally and vertically, meaning it has been shifted from top to bottom or from bottom to top, and it has also been shifted from left to right or from right to left. It doesn't matter. This also here is literally just g of x shifted vertically and horizontally. Charlie, you see, it's not like a guess, it's more like intuition. Apart from it just being intuition, it's just how it is with some of these questions, you see. And you can see it's like the last question. So me having to have said what I've said, let's read the question again. It says here, use the graphs of f and g to determine the number of real roots of
Levi,
this equation. What's up?
can I stop you? Like, I would like
Please
for
do.
the vertical and horizontal shift, right? Like, can't you look at like with your previous equation that we made for g of x? Remember, we look at like our p and our q's, so that determines whether there was a shift. So like for whoever, you can look at your p and your q. So if you see your p is different and your q is different, then you know exactly there was a horizontal or vertical shift. And when you
Go on. Oh yeah, I was
Okay.
saying yes, ma'am. Sorry, I
Okay.
interrupted you.
Okay.
I was-
Even
I
with
was-
your f of x, same applies. You look at like your y asymptote and your x asymptote. So you can see there's no -1 next to the x, and you can see from 4 to 5 a -5. So you can see there was a shift. So you can look at those things for you to know whether it was vertically or horizontally.
horizontally. Thank you very much, Madam. Thank you so much. Yeah. So for those that are wondering, I'm not like trying to take any credit now, but then like Chloe has been going deep in the online courses. Yeah, and it shows. It shows. It shows. So yeah, basically what she said is 100% what we're saying now, right? That the reason why we know that these have been shifted horizontally and vertically is mainly because if you're comparing these original equations, right? And you're comparing what you're seeing here, all that has happened is, for example, the 2 over x here, you can see the +1 is gone, you see? And that's how you see that it was moved horizontally, like from left to right. Because anytime you move a graph from left to right, directly where x is, it gets affected, you see? So if it was a +1 here and now you see there's nothing, it means that clearly the graph was moved to the right 1 unit. I'll repeat, because there's a +1 here, right? For you to end up with this, let's actually just do it nicely and slowly to see what has happened from f of x to get this here. So for the blue, all that has happened is, right, all they did was they took the equation of f of x, you see? And then what they did was, clearly, they moved, I'll say it and then I'll write it out. They moved the graph 1 unit to the right because they +1 here. I mean, they -1. So a +1, if you minus a 1 here, you end up with nothing, you see? And then from top to bottom, for you to go from a +4 to a -5, clearly they moved the graph 9 units downwards, you see? So let's just put it that way. Let's just write out what has happened from this original f to this one. So vertically, it was moved 9 units down. The reason we're saying it's 9 units down, it's because it's from a 4 to a -5. So from 4 to -5, you're going to go down 9 times. For the horizontal shift, we said it was moved 1 unit to the right. The reason we're saying it was moved 1 unit to the right is because directly next to x here, you're starting off with x +1, and you're ending up with technically x +0. So because you now have a 0 directly next to x, it means that what happened was this whole equation was moved 1 unit to the right. Because if you move your graph 1 unit to the right, this is what you would write out. An equation moved 1 unit to the right. Wherever x is, you would subtract a 1 there. Meaning that in your equation, down here where x is, right? Directly here, down here where x is, wherever x is, you would throw there x -1, and then this +1 is just there, you see? And then, I mean, like the 4 would have just been there. Doesn't matter. That's not our focus for now. Our focus is just what has happened from left to right. So when you would have simplified this, you would end up with like 2x plus a 0 there, but you don't write the 0. And then you would have your +4 there. This is what it would look like the moment it was just moved 1 unit to the right. But then the moment they also then moved it up and down, it then affected the 4 there. So we're dealing with the horizontal shift for now before working on the other graph. So we say here horizontally, it was shifted 1 unit to the right. It was moved 1 unit to the right because from +1, if you -1, that's how you end up with a 0. And that's a shift to the right because that's how it works with x. For G, we can also try and see what has happened horizontally and vertically. So horizontally, I think is the easiest one to start with. So you can see that here you started with like having a -2 here. And now here you have a -3. So obviously from a 2 to a minus 3, it means that here you had minus 1 somewhere, you see, meaning that in the equation of g, what happened was this. Wherever x is, you're going to put x minus 1. This is to show that you're moving your graph 1 unit to the right as well. You see, because I mean, like if you move this graph 1 unit to the right, that's how you're going to end up with x minus 3 here. I think looking at it with the image is going to be a bit easier, because if you look at it nicely, right? Where's this thing here? Where's this parabola? Oh no, yeah, this is our parabola. So with our parabola, if you look at it nicely, right? If you move your graph 1 unit to the right, your turning point is going to be somewhere there, you see, and the x value of your turning point is going to be a positive 3. Now, if your x value of your turning point is a positive 3, inside the equation, you would see it as x minus 3 over there, because remember we said in the equation, you always take it as the opposite compared to the image. So moving 1 unit to the right is how you see that there is a minus 3 there, because from a minus 2 to a minus 3, you minus a 1, and minusing a 1 is moving 1 to the right. Yep, yeah, I think saying it out loud sometimes is just a bit weird because you're minusing, but you're still moving to the right. So horizontally, we said it was a shift 1 unit right. So we said here, compared to this -4 and this +4, we can see that from a 4 to a -5, this was clearly moved 9 units down, you see, because I'm like from a 4 to a -5, it was clearly moved 9 units down. So vertically, we said 9 units down. Okay, so this paints a very, very clear picture to us, because I mean, like we did the homework, as you saw. We said that, okay, compared to F and G, if you look at F and G compared to this is clearly the graph of F moved around. This is clearly the graph of G also moved around. So we then said, okay, fine, let's go and see the specifics. And we said this was moved 9 units down and 1 unit to the right. And then we're seeing the exact same thing for G. It was moved 9 units down and 1 unit to the right. So now we can understand the question better. The question is saying use your graphs of F to determine the number of real roots where this equation is equal to this equation. Give reasons for your answer. So when they're asking for the number of real roots, firstly, before we think of number of real roots, let's just talk about real roots. So them referring to real roots, they are literally talking about points where they meet. See, those are roots. Roots are cases where your graphs meet each other. So if you're looking at the original sketches here, there are no real roots here, because firstly, if you look at where G is not touching F anyway. F is not touching G anyway. This original picture, there are no real roots. That's for the original picture. The reason why there are no real roots is because there are no points where they meet. You see, that's for the original images. They have no real roots because they have no points where they meet, because real roots just refer to points where they meet. So it makes it easier now when you're even looking at the equation here, because this equation is telling you that these two graphs were both moved the exact same way. So this is asking where will they meet each other. So logically speaking, right, if you see these two graphs here, right, I mean, like the way that they are, if they all both move exactly the exact same way, if they are all moved 9 units down and they are all moved 1 unit to the right, I mean, like hypothetically speaking, they'll still never meet anyways. The reason why they'll still never meet is because the asymptotes also move as the graphs move. You see, as you can see here, this asymptote is telling you that your turning point will always go up until the asymptote. This, oh, wait a minute. No. I think this confused me. Nope. The number of real roots, they do have real roots. And this is the reason. This is an asymptote for your exponential, your hyperbola, yes. but then your parabola is not restricted by that asymptote. If you look nicely here, your parabola is gonna go down forever. And your hyperbola, it's not gonna have an x value of -1, yes, but then at some point in time, it is gonna touch the parabola. Yeah, so I guess I was woodwinked there. I won't take this back. I will change it. So the number of real roots, so when I said I'll change it, I just mean, so the number of real roots here, it looks like we have one real root. Because if, I mean, looking at the way it is originally, it looks like it's not gonna have real roots, but then you saw how I was almost woodwinked there. Because I mean, like the sketch ends here, but then we know that hypothetically speaking, because arrows, it means that this is gonna carry on forever. So this has one real root. That's the original image. So if you look at it, if you think of it nicely, if this original image, right, was moved 9 units down and 1 unit to the right, if everything was moved 1 unit down, and I mean, if everything was moved 1 unit to the right and 9 units downwards, these graphs would still only meet at one place, you see. So you have one real root because there is one point where they meet. You see, that's for the original sketch, but then it's gonna stay the same if they're both moved the exact same way. So for a good 4 marks here, we literally just have to say words. So let's say here the graphs, or rather the equations, because that's the question. Use the graphs of blah 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 to determine the number of real roots of this equation. So we're going to say here the equation has one real root. That's going to give us a mark. The equation has one real root because the graphs of f and g meet only once. Full stop. Now you have to justify why this is coming from the graph of f and g. So we say the equation has one real root. That's going to give us 1 mark because they asked how many roots. We said it has 1. And now we're giving a reason because the graphs of f and g meet only once. But that's not all. So we're saying that it has one real root because the graphs of f and g only have they only meet once. And here we're going to say that the equations on both sides of the equal to sign are the graphs of f and g shifted 9 units down and 1 unit to the right. So they will also only meet once. You see, the rest here is definitely worth the other 2 marks because here we said that the equations on both sides of the equal to sign, meaning this equation here and this equation here, the equations on both sides of the equal to sign are the graphs of f and g. Yes, they are shifted 9 units down and 1 unit to the right. So they'll still only meet once. That's going to be good enough for 4 marks. And you can see how the theory or the background knowledge of functions and graphs is important. You can see it's important for these questions here, the 4-mark question here and the 4-mark question there. That's like a whole 8 marks. So over time, if you keep finding yourself like leaving these questions out, yeah, those things kind of pile. So this is just to show that for you to be able to understand these kinds of wording, this kind of wording, you just need to go through like similar examples until you can see, okay, fine. If they mention real roots, they're just talking about points where they meet. if they're referring to stuff like this, don't just think of this as like new things. It's always going to be referring to what it is that you were just working on. And take note of how when I looked at this image, I said there are no real roots, which was like a big mistake because of how it looked. But then we said that this asymptote only applies for our hyperbola. Our parabola can still cross it. And the moment our parabola crosses it, it's eventually going to touch our hyperbola at some point in time. But it's only going to do it once, you see. So that is that for. Oh, there is a question. Let me see if someone asked anything. Nope. But yeah, this one is quite a mouthful. I'm not gonna lie. But it is what it is. Let me actually maybe just stop this recording for now. I think that will probably be it.